In this video, we're going to take a deeper look at passing arguments to functions. Now, in most programming languages, you have what are known as pass by value and pass by reference. With pass by value, you pass a copy of a value into a function, and because it's a copy, the function can do whatever it wants to the copy without having any effect on the original value in memory, wherever that may be. Many languages also support pass by reference, where the called function is told this is where you can find the original data in memory, and therefore the called function, having access to the original data, is able to potentially modify and manipulate that data directly. Now in Python, everything is passed by reference because everything is an object, and we don't directly manipulate the objects, we manipulate the references to the objects. So when I pass a reference to an object into a function, a copy of the reference is made, but not a copy of the object itself, which turns out to be really important for performance, because as you start getting into big data, the objects that you're manipulating may contain enormous amounts of information, which if we had to copy that data into a function would take significant compute power. So in Python, just reiterating, when you have a variable that refers to a value, the variable is someplace in memory that just contains addresses of objects and the names by which we refer to those objects. And then elsewhere in memory are the objects themselves. So this would represent a case where we had said assign to the variable x the value 7. So now that we've introduced the concepts of pass by value and pass by reference, let's try to hammer this point home a little bit more with an IPython session. And let's start out with the variable x initialized to 7, which creates the variable that we just showed you in that preceding diagram. Now it turns out that every object in memory at a given time has a unique ID associated with it, and you can access that information via a function named ID. So for example, if I go ahead and say give me the ID of whatever x refers to, it's going to give me back a number, and by the way, that number will probably be different on your system, and if you execute separate IPython sessions, each IPython session will probably have different numbers as well. This number is known as the object's identity, and in many Python implementations this is actually the memory address of the object, but that is not required, so you certainly shouldn't rely on it being the memory address of an object. Now, to help me get through this a little bit easier, rather than typing a function definition, I'm going to paste one in for a function called cube, which is going to calculate the cube of whatever number you give it. And what I want to do is demonstrate what the ID is of the variable that we receive, or of the object that we receive into the parameter called number. So the first thing we do is define this function. It's going to print out that ID, then it's going to return the cube of number. So let's define that, and let's go ahead and call cube with the number 7, and we can see that the ID is identical to back in snippet 2. So the object that we're manipulating inside the cube function is in fact the object that x refers to, that initially contains the value 7. Now we didn't modify x, so x still contains the value 7 after the call to cube in this case. However, it is possible that we can write functions that modify objects as well. Now it turns out there's also another operator that can help you understand this as well. It's an operator called is, which you can use to test whether two objects have the same identity. So let's go ahead and paste in another version of the cube function here. In this case, we're introducing the is operator, and what we're going to do is print out number is x, and we're going to see a Boolean value, true or false. So if number and x are the same object, that is, they have the same identity, then we'll get true. If they're different objects in memory, we'll get false as a result of that. So if I define that, and now once again, let's go call cube, and we'll give it x as an argument. And we can see that number is indeed x. They are the same object in memory. Now it is possible to pass both mutable and immutable objects as arguments to functions in Python. If you pass a mutable or modifiable object, you'll be able to change the original value in the caller. However, if you pass an immutable object, and there are quite a number of those in Python, then any changes that appear to be made to the original object are actually creating new objects in memory. So to help with this point, let me grab another copy of my cube function here and paste it in. And so here we've defined another version of the cube function, and in the block of that function we're going to go ahead and display the ID of whatever object we're receiving by reference into the variable number. Then we're going to try to modify that object. Now, number is a local variable. It's the parameter of the cube function, and it's a copy of the reference that was stored in the variable x and passed into the cube function, as we're going to make that call in just a moment in the next snippet here. But because it's a copy of the reference, it's still referring to the original integer object in memory, but integer objects are immutable. So anything that looks like it modifies an integer actually creates a new integer object in memory. So we cube number, store the new reference in number, and then to prove to you that it's a different object, we once again display number's ID, then we return number to the caller. So let's now call cube to see what happens here, and we'll once again give it the variable x, and as you can see, as we come into the function, x has the ID shown here, which is the same ID that was displayed up above. If we scroll back up, there's that same ID again. And after we do the cube, we have a new ID, a physically separate object in memory. And of course, you can go and check the ID of x to see that it's still referring to the same object that it started with, and indeed it is the same ID once again. So when you are working with objects in Python, they are passed by reference into the functions, and we were able to prove that by displaying the IDs of the objects before and inside of the calls. But certain types of objects are immutable, and therefore the function is unable to modify the original object in memory. So some of the immutable items in Python include the numeric types, integers and floating point numbers, strings, tuples are immutable as well, and there are a few other items that we'll see in later lessons.